This first timer example is going to take a look at some idiosyncrasies of the scan and some ways that you can use the ladder logic here with timers. So if you look at my circuit here, I have a PB1 start. So what that's going to do, because the done bit's true, is it's going to energize the timer. And I'm going to use the instantaneous contacts of the timer here to hold the timer on, and you'll see that the timer will time on and this light will come on. When that times out, the timer's done and it resets. So let's just check the operation of these first two rungs using the timer EN for memory. So if I momentarily make the start, you'll see the timer is timing, the light is on, and then it goes off. It is reset because it's not a retentive timer, and so when this gets done, it opens up and it resets itself. So that's pretty common, to use a timer to get done to then reset itself and not have to use an RTO with a separate reset. Okay? So the next part of this is we were getting the light on here for the timer timing. And so if we looked at this rung down here, it says, what is faster, the done bit or the timer timing? So we've got one timer here. So what we're trying to do is we're trying to get memory right here for the light. So when we start the top circuit and it gets memory and the timer is going to be timing for 4 seconds, or excuse me, for 5 seconds, well, this is not done until after 5 seconds. But the timer timing is going to be true during that 5 seconds it's timing. And so the question is, what's faster? This is going to get done, and it's first in the rung, and then the timer timing is going to switch. So just for a millisecond, or for just one scan, will this be true and this be true at the same time, causing this light to come on, which would cause memory. Okay? So that's what we're going to look at. So here we go. I'm about to start the push button here, right here. Watch this. Ready? Okay, the timer's timing. My timer timing is true. Is this going to get done? Well, the light did not come on. What does that mean? That means that this came high, or came true, at a different time when timer timing was true. Or it means that the timer got reset before the done bit came true. Well, let's consider that. First of all, the timer did become done, and we know that it became done because it reset itself. So we know that the T44 done bit was indeed changing states, or getting a 1 in it. So that means that this, even for the shortest of time, must have been true. So how come this one wasn't true? Well, if you think about the order of it, what it does is it becomes its timing, and then right at 5 seconds it stops timing and then becomes done. So because it stopped timing, this went from true to false, and then immediately thereafter this became true. So neither the done bit and the timer timing were not at the same time. Let's watch it again. I click the switch. The timer timing is true, and at 5 seconds it's no longer true. It goes false. This briefly comes true, but they're not true, so it doesn't hold. Okay? So I guess if we modified this a little bit, and I made this, maybe I'll make this no, I'll change the instruction type on this. Okay? So change instruction type to an XIO. Okay? And I'll come right here. I'll check it. And then I'll compile it, test them, yes, and then I will assemble them, and now we're ready to try it again. So this time, the timer timing, when I hit the switch, it's going to make this false, and so what will happen is it will stop timing first after 5 seconds, which would then return it to true, and then get done. So let's see that. I'm going to hit the switch again up there. It's timing. Because it's timing, this becomes false. And then it returned to the true state. And now my light is on, which means that this done bit right here came on for the briefest of seconds. So this timer right here was timing. It got done, and it executed the done on these rungs here. None of these rungs had the done bit on them, but this rung did have the done bit on it, so it got a 1 written in there. This is returned back to 1. It became true. And then when it started the next scan, what it did was it changed the status of this back to open, which would or back to closed, which would reset this, which would turn this off, and so the timer got reset. But we briefly had this rung right here true, causing it to hold itself. Okay, I'm going to go ahead and hit the stop button, and that will reset everything. All right, now this says, is it okay to replace the timer timing with a bit? So let's just say I had timer timing closed and I put a bit right there, bit 30. So if I came here and basically it's asking, can I put it like that, right? Closed. And so if I come here and start putting this back together and then assemble it. Okay, so now isn't that kind of like the same circuit? Instead of having a closed timer timing, I just had the timer timing doing a bit and then the bit here. Okay, so will this get the light to latch on? Well, here I go again. I'm up here, I hit the 1 and I let go. It's timing for 5. Ooh, the light did not come on, right? So what happened here? Well, what we have is, I guess, like a double negative. Before we had here a closed timer timing bit. Okay, so basically we moved that closed timer timing bit up here, and then we associated it with a bit, and then instead moved the bit down here to the closed. Okay, well, we have the double, like a double knot. So this is a knot right here because it's a true contact. It's shown as a closed, shown as a true contact to start with, which makes this bit true. Okay, and then when we applied it to the closed contact here, that opened it. Okay, so before we just had the timer timing here and it was true because it was closed and it had a 0 written into it. See, right now this is showing closed, but there's a 0 written into this because nothing's happening. It's not timing. But what we have here is if we close it, it's a 0 here, but making it true. And if this rung's true, this bit gets a 1 written into it because it's logically true here. And then that light bit causes this, which would normally have a 0 in it, meaning it was true, to get a 1 in it. And the 1 makes this false. So you got to be careful when you address like a double knot here, a double negative, because it will cause your output to change state. Hopefully that makes sense to you.